Hi there, welcome to this video. It is designed for Year 13 pupils studying Maths A-Level, Daily Maths 9, time for your pure stats and mechanics to shine. So here we go, this is the 1st of January, starting off with some questions on sequences and the binomial. I suggest you pause the video now, have a go at these 3 questions, and then press play and watch my solutions. So this first question, we're given a summation is given by this formula here, and we're just asked to find the sum of the terms from 10 to 20. So if we use the formula from r is equal to 1 to 20 and find what the sum is of the first 20 terms. So if n is 20, we're going to put 20 over 2 times 3 plus 5 times 20, which is 3 plus 100. 20 divided by 2 on the front is 10, and 10 times 103 is 1030. Now what we need to do to get the terms from 10 to 20 is take that value 1030 and take away the values 1 to 9. And then that will leave us what the sum from 10 to 20 is. So just finding the first 9 terms, n is now 9, so 9 over 2 times 3 plus 5 times 9, which is 45. So 48 times 4.5 comes to 216, and if you take them away from each other, the answer is 814. Now in the second question, we've got a geometric series, and how do you get between the terms? You times by r, and then from that term to that term you would times by r. So it's the same r that gets you between all the terms. So if we take a future one, take the second term and divide it by the first term, that will give us r, and the same r will be what we get when we do 4x minus 2 divided by the one before that. And if we just cross multiply, we're going to get x squared plus 2x plus 1 is equal to, times in those two together, 4x squared minus 14x plus 6. And then if we take everything to one side, you're going to get 3x squared minus 16x plus 5. And if we just factorize that, we'll get 3x and x, a 5 over there to make the 15. Signs have to be the same and both are negative. So x is going to equal 1/3, or x is equal to 5. The next one, we're doing a binomial up to the x3rd term, so replacing that square root with 1 minus 4x to the half, and then using the formula that you do get on the formula sheet, it's going to be 1 plus nax. N is the power on the bracket, so that's a half, and ax is here but with its sign as well, so that's going to be minus 4x, and then it's going to be n, and then n minus 1 all over 2 factorial ax all squared, and then plus half minus 1 minus another 1, which is minus 3 over 2 all over 3 factorial, and then that would times by minus 4x cubed. And if you tidy them all up, you get 1 minus 2x minus 2x squared minus 4x cubed. Two more pure questions. We have got this sector here. Now we're told that the area of the sector is 11. When you're in radians, the area of a sector is half r squared theta. That's equal to 11. Now we need another equation because we've got two unknowns, so we need some more information, and we're given that the perimeter of the sector is 4 times the arc length. So arc length when you're in radians is equal to r theta, and the perimeter is going to be that arc length plus 2 r's. Now we're told that the arc length times 4 is equal to the perimeter, so r theta plus 2r, which is the perimeter, is equal to 4r theta. Now if we just tidy up, if we take that r theta to the other side, 2r is equal to 3r theta. If we cancel by the r's, we're going to get that theta is equal to 2/3. Now if we put that back into our first equation for the area, we're going to get half r squared times 2/3 is equal to 11. The 2's will cancel, we can take that 3 up. R squared is equal to 33, so r is equal to the square root of 33. Next question is about theta when it is small and measured in radians. So when theta is small, sine theta is equal to theta and cos theta is equal to 1 minus theta squared over 2. So we've got this expression here, we've got to try and find what it's approximately equal to. So 4 sine theta over 2, so because we've got this theta over 2, whatever that theta is, it just goes for the sine of it becomes itself, so that's just going to be 4 times theta over 2 plus 3 cos squared is going to be 1 minus theta squared all over 2 all squared. So the 4 will cancel with the 2 and we'll get 2 theta plus 3. Now I'm going to make this in the bracket have a common denominator, so that will be 2 minus theta squared all over 2, and that's all squared. So we need to square the top and square the bottom. So this is going to be 2 theta plus, now the 2 on the bottom squared is going to be a 4, so that's 3/4. Squaring out this on the top is going to be 2 times 2, 4, minus 4 theta squared, and then plus theta to the 4. Now times in that 3/4 in, I'll get 2 theta plus 3 minus 3 theta squared. I'll also get a plus 3/4 theta to the 4, but it's not wanting that theta to the 4 term because I just want up to the theta squared term. So putting it in the order that we've got here, it's the constant first, that's 3, plus 2 theta minus 3 theta squared. So here A is equal to 3, B is equal to 2, and C is equal to minus 3. On to the stats questions, and first question we have got a probability question. Always a good idea to put the information on a Venn diagram. So we've got 2 events A and B. We're being told not in A intersections with B is 0.22, so that is that section there. Not being an A intersection, not being a B must be on the outside, 0.18. Probability of A is 0.6, A given B is 0.6, and A intersection B is 0.33. So the 0.33 goes there. Determine whether A or B are independent. Now we're told that the probability of A is 0.6, so the probability of B is these two added together, 0.55. Now events are independent if the probability of A times the probability of B is equal to the intersection of the two. So the probability of A we're told is 0.6. We can see the probability of B is 0.55. Now when we times those two together, that does give us 0.33, which is the intersection there. So this statement holds true, and it only holds true when we have independence. So A and B are independent. Okay, the next one is hypothesis testing. We've got a potter believing 20% of the pots break whilst being fired in a kiln, and we've got batches of 25. So we're letting X denote the binomial distribution where we've got batch of 25 and the probability P. Our null hypothesis is currently what's going on, that 20% breaks, so that's 0.2. Our alternative hypothesis, because we're being asked to do a two-tailed test, is that the P does not equal 0.2. So if we assume that H0 is true, then X will be binomially distributed with 25 and 0.2. So that means for every 25 pots, 1/5 will break. So we're going to be expecting 5 in every 25 to break. So what is the probability of something extreme from our expectation of 5? Is that going to be lower than the significance level? Now, when we're doing a two-tailed test, we can split that up as 5% in each tail. And what we're looking for is the probability of something extremely away from the 5 that we're expecting to be lower than this significance level. So we just have to have a think, and if you just play around with it, if you find the probability that x is less than or equal to 1, that comes out to be 0.027. Now the probability of x being less than or equal to 2 comes out to be 0.098, so that's bigger than the 5%. So x being less than 1 is the lowest one that will be in the critical region. And then if we do on the other tail, x being bigger than or equal to 9, now what we'll have to do there is do 1 minus the probability that x is less than or equal to 8. If you do that on your calculator, it's 1 minus 0.9532, which does come out to give you 0.0468, and that is less than the 5%. So these are the two regions that give us the critical regions. So as long as x is between 0 and 1, and then if x is bigger than 9 and less than obviously our 25, this is our critical region. Last two questions. These are our mechanics questions now. A car moves with constant acceleration. As soon as you see constant acceleration, you're going to be thinking Suvat equations. So if I write my Suvats out and start filling in, we've got a car passing point A with speed of 5. So that will be our initial velocity. 4 seconds later, it passes B, where AB is 50 meters and the acceleration is 3.75. Now, we've basically got all those details, but what we're being told is when the car passes C, it has a speed of 30, and we're trying to find the distance AC. So what's going to be a good idea, because we haven't got that much information about from B to C, is find this final velocity when it passes through past B, and then use that to go from B to C. So we can use V is equal to U plus AT. So V is equal to 5 plus 3.75 times 4, and that comes out to be 20. And then from B to C, if we do another set of Suvats, our constant acceleration is going to be 3.75. Our initial velocity is going to be the same as the final one there, so that's 20. We're being asked for to find the distance A to C. When we go through C, the speed is 30, so that will be our final velocity. We're interested in the distance, so I want a Suvat equation that doesn't involve time. So V squared is equal to U squared plus 2AS. V squared is going to be 900, U squared is 400 plus 2 times 3.75 times S. Now, if you just rearrange and find S comes out to be 66 2/3 meters, but that's the distance from B to C. So the A to C is going to be 50 plus the 66 2/3, which is 116 2/3 meters. Last question, we've got this equation here, which is the velocity as a particle moves along the x-axis. Find the time when P is instantly at rest. It's going to be instantly at rest when the speed here is equal to 0. So we say 2t squared minus 14t plus 20 is equal to 0. All those terms are even, so we just divide by 2. And then we can factorize. We're going to get t and t minus a minus 5 and 2. So t is equal to 5 or t is equal to 2. And they will be in seconds. Thanks so much for watching. Hopefully you found this video useful and helpful as you're preparing for Maths A level. Do check out the channel, like and subscribe, and I will see you on the next one.